Assalamu alaikum. This is MD Shakadushan Chaudhary Shubho. My ID is 12108014. Today I am going to present image enhancement in the frequency domain. Image enhancement is an important topic in digital image processing. It helps us to improve image quality by removing noise, smoothing images, and making details clearer. Let's begin. First, let's understand what image enhancement is. Image enhancement means improving the appearance of an image. There are two ways to enhance images. The first is the spatial domain, where we work directly with the image pixels. The second is the frequency domain, where we work with the frequency information of the image. The final goal is to improve image quality and make important features easier to see. To work in the frequency domain, we use the Fourier transform. The Fourier transform changes an image from the spatial domain to the frequency domain. In the frequency domain, we can study different frequency components of the image. This helps us to perform filtering and image enhancement more effectively. An image contains low frequency and high frequency informations. Low frequencies represent smooth areas and general shapes of the image. High frequencies represent edges, details, and sharp changes in brightness. By controlling these frequencies, we can smooth or sharpen an image. The two-dimensional discrete Fourier transform, or DFT, converts an image into its frequency representation. This formula may look complex, but its main job is simple. It changes image data from the spatial domain into the frequency domain. After applying DFT, we can perform different filtering operations. After processing the image in the frequency domain, we need to convert it back. For this purpose, we use the inverse DFT. The inverse DFT changes the frequency data back into the image form. This gives the final enhanced image. Filtering in the frequency domain follows three steps. First, we apply DFT to the image. Second, we multiply the image frequencies by a filter. Third, we apply the inverse DFT. This process helps us to remove unwanted frequencies and improve image quality. There are some important properties in the frequency domain. One important property is that multiplication in the frequency domain is similar to convolution in the spatial domain. The frequency domain is also useful because it makes many filtering operations easier and faster. These properties are very helpful in image processing. There are two main types of frequency filters. Low-pass filters allow low frequencies to pass and remove high frequencies. These filters are used for smoothing. High-pass filters allow high frequencies to pass and reduce low frequencies. These filters are used for sharpening images. Now we will discuss smoothing filters. Smoothing filters reduce noise and make images appear smoother. The three common smoothing filters are ideal low-pass filter, Butterworth low-pass filter, and Gaussian low-pass filter. The ideal low-pass filter passes frequencies below a selected cutoff value. All frequencies above the value are blocked. It is simple to understand and implement. However, it often creates unwanted ripple effects around the edges. These effects are called ringing. The Butterworth low-pass filter provides a smoother transition than the ideal filter. Instead of sudden cutoff, it gradually reduces frequencies. Because of this smooth transition, it produces less ringing. It is widely used in image processing applications. The Gaussian low-pass filter uses a Gaussian curve. It provides the smoothest transition among the low-pass filters. It removes noise effectively and produces very little ringing. Because of these advantages, it is one of the most popular smoothing filters. Now let's discuss sharpening filters. Sharpening filters increase image details and make edges clearer. The three common sharpening filters are ideal high-pass filter, Butterworth high-pass filter, and Gaussian high-pass filter. The ideal high-pass filter blocks the low frequencies and allows high frequencies to pass. As a result, edges become stronger and more visible. However, it can also create ringing effects. So, it is not always the best choice. The Butterworth high-pass filter provides smoother sharpening. It enhances edges while reducing unwanted effects. Compared to the ideal high-pass filter, it produces better visual results. It is commonly used in many image enhancement tasks. The Gaussian high-pass filter also enhances edges. It provides very smooth sharpening and almost no ringing effect. Although the sharpening may be slightly weaker than the ideal filter, the image quality is usually better. Now let's compare these filters. Ideal filters have sharp cutoff but produce more ringing. Butterworth filters provide a balance between sharpness and smoothness. Gaussian filters provide the smoothest results and the least ringing. In many cases, Gaussian filters give the best visual quality. Frequency domain image enhancement is used in many areas. It is used in medical imaging to improve scan quality. It is used in satellite images to see details more clearly. It is also used in computer vision, face recognition, and industrial inspection. These applications show the importance of frequency domain techniques. To conclude, frequency domain enhancement is a powerful image processing technique. The Fourier transform converts images into frequency information. Low-pass filters are used for smoothing. High-pass filters are used for sharpening. Among different filters, Gaussian filters usually provide the best visual results. Thank you all for listening my presentation. Do you have any question? Feel free to ask me.